Okay, perfect. Thank you for joining in today as well. So this week we will continue on the workshop. This week we're now starting deep diving into more cloud related technologies. This week will be all about this session as well about cloud itself, the cloud. We will start talking by defining what the cloud is. Soon after, we will move to talk about the main cloud providers, some past experiences as well with those cloud providers. Then we will talk about cloud migrations, which is one of the key components and concepts that we as cloud engineers, DevOps engineers do, or at least in terms of working with multiple cloud and where the industry is going to. Soon after, we will end this session talking about the cloud well architected framework, which is a set of principles and guidelines that the cloud have worked together in order to move the adoption and apply best practices when working with the cloud. So without further ado, let's start with Mimi. So in here we can see what the Simpsons started doing like a couple of years ago, doing some future references of new or present things. So in here we can see an old man yelling at cloud. So this can be referred as all engineers that most of the time are having issues working with the cloud, and they have issues with the systems and whatnot. So yeah, at the end of the day, we are now in a trend, an industry that is moving and shifting everything from data centers into the cloud. And when we start hearing the cloud, we try to figure out what it is, right? So in terms of definition, you can start by this simple one. The cloud is made of servers in data centers all over the world. That's pretty much summing it up. The cloud is just a connection and a connection from our computers, from users into a data center. So before, data centers were literally private. In order to have a computer or a server, you need to reach out to a specific provider, and from there create a server, and then you will be able to deploy your application and whatnot. But now, that concept has evolved to be like a really, really public service on where people can just add a credit card and then spin up specific services. In this case, the most services that are used are servers, and that soon after can be connected to a specific endpoint, and then it can be fully reachable by end users in a matter of minutes. We were discussing before the evolution of the physical servers into virtual machines and then into containers. So this has also been really possible by the evolution of the cloud, of companies being able to provision your specific infrastructure, your server needs, and being able to access them worldwide in terms of minutes. So has been a great evolution from what we moved from physical servers into servers in the cloud. So talking about services and how the cloud is composed and separated, we might be thinking of the cloud as AWS, Azure, GCP, but nowadays a lot of services and a lot of products are now being evolved into these platforms, into this software as a service itself. So we can see that if you are accessing Gmail, if we are accessing this Google Meet, you are already using the cloud in a way, the actual service. So we can see different four categories on how we can consider the cloud, and of course these terms have been evolving as well to the point of there are some specific roles now that have evolved from the DevOps engineering to platform engineering, or just SRE engineering, that are applied to software as a service, platform as a service, infrastructure as a service, and on premises, right? So in here we can see like the main difference between these two categories. The colors in here that represent the customer responsibility, and then the other color, the green one, is the cloud service provider responsibility, right? This is being called as the shared responsibility model that all cloud providers have. They will say, hey, we are in charge of, for example, doing the physical access to the servers. We are in charge of that. You don't need to worry about who can access the data centers. A hacker cannot enter a data center. It's not your problem, it's ours, on the terms of the cloud provider. Whereas the responsibility of the user is manage the guest operating system, right? So again, that's a specific example. So if you go to, like, for example, the on-premises, you will see that everything is about the customer responsibility. If you manage like a, or in the previous times on where we will working with data centers, you will be able to manage, or you will be in full charge and responsibility of managing all of this, from the physical layer to the infrastructure side of servers, networking, managing switches, networking cables, etc., to the point of doing also the virtualization, jumping into the guest operating system, managing updates, and managing, upgrading your operating systems to the latest versions and whatnot. Then, of course, your application, the application that you are developing, of course, managing the data. And later on, the user and access identity. So if you can see this actual scale, you will see from the very bottom, the actual piece of hardware, until the more abstract way of managing your data and user access. So that was on premise, right? Soon after, we started working with infrastructure as a service. So this can be related to all three main cloud providers, AWS, Microsoft Azure, and Google's GCP. So in here, what they provide to you is that they will manage, the physical data centers, the infrastructure, the racks, the servers, those servers, the networking, the cables, and everything. It's managed fully by the cloud service provider. So you do not need to worry about that. And also the virtualization, right? So at the end of the day, what you will have is, like, you will need to worry about the guest operating system. We, as DevOps engineers, cloud engineers, we always need to worry about doing updates and patches into, the actual servers, doing the application, of course, the data and user access and identity, right? So this is the core concept of infrastructure as a service. That's the main concept that evolved from the very beginning back in 2006 when AWS released S3, the main bucket for storing data in the cloud. So, you only worry about the data or the user access identity. But then, has been evolved to the point that if you go and create a new AWS account, a new Azure account, you will be able to provision a server. And, you will be able to, and you will need to worry about the guest operating system to up. And then, that evolved, that term evolved, and, then evolved to platform as a service. So now this is a new type of cloud itself, on where you will not be worrying about guest operating system. You will then just be worrying about your application data and user access identity. And again, this has been, the trend that we have seen for the last 10 years now, on where cloud providers, major cloud providers, are now offering services on where you literally forget about, the most down parts of this diagram. Where in here you need to worry about the guest operating system, right? And now you do not need to worry about the guest operating system, just your application. And soon after, we jump into software as a service, on where you do not worry about the application nor the guest OS. You just worry about your data and your user access, right? These specific services, we can see them mostly, like, for example, Gmail, this Google Meet. These are software as a service, on where we as user, we only worry about the data that we are sharing, emails that we are sending. If you're working on Google Docs, you will be just worrying about the data and the user access identity. You will not worry about your application and how the application is released. Whereas, platform as a service, you will be in charge of doing that application, right? For example, there's an application that we are working internally here at Admios, on where, we are working fully on the application itself. So end users will only need to worry about application data and user access identity, and not the guest operating system, right? That will be for the team developing and deploying the application. In this case, it's me. So I will need to worry about the guest operating system, since we are using infrastructure as a service, right? In this case, AWS. So in a nutshell, again, this is really the main difference about the cloud, the type of cloud, and then, also the shared responsibility model, on where what we need to worry about and what we don't. So soon after, we will start talking about the main cloud providers. So again, I was able to just talk about the three ones, GCP, in this case, AWS, and Azure. There are others out there, there are, since this is an evolving technology and an evolving industry, there are new cloud providers joining, the forces, and joining, the customer share. So, we can talk about Oracle's cloud, IBM cloud, and even one that is getting a lot of attention back in Asia is Alibaba Cloud. So these other, hadn't had that adoption, at least on these parts of the world, but they are growing in a way that people, in terms of moving from these three main cloud providers, are trying to shift to these smaller ones, just because they provide perhaps better pricing and some other opportunities to enterprises. But day to day, if you go and search for a job or try to see job positions for a DevOps cloud engineer or something related to that, you will see that these are the three main cloud providers that on where we are deploying applications, right? If you go into the developer's point of view, you will see that the main cloud providers are these three as well, on where you will be deploying, or at least you will be executing your commands or your applications into these cloud providers. So that said, we have GCP, which is from Google's one. Again, all these specific applications, in this case, infrastructure as a service, from all three providers. It's interesting to see that they build these applications, the cloud itself internally. And the first one was Amazon, to realize that this was like an opportunity of doing business, and they had this virtualization system in place already. So what they did is that they just put that to market, to be able to have users use their systems and their data centers that they already had. And from that point on, the explosion, I would say, explosion of adoption to the cloud was really, really impressive and huge, where to the point that everyone now is trying to move off to the cloud, just in terms of cost effectiveness, and also to be able to deploy and reach out end users faster. So GCP has, at the same time as the other, they separate their services by the capacity, or what is the purpose. Like, for example, the compute one, the storage ones, the big data, machine learning, and from there you can see the actual services that they have. So, for example, every single cloud provider calls their services differently. So
I lost the audio. Yeah.
hey, can you guys hear me? Sorry, I think I lost
Now we
connection
can.
for a second.
Yeah, now we
Yeah,
can.
thank you. So yeah, what I was saying, sorry for that, is that yeah, the cloud providers have evolved to separate their services into specific, parts. So for example, compute, you will have App Engine, Compute Engine, and these same services you will have the same services in AWS, in Azure, but of course with a different name, with a different logic, but they offer the same, right? Because they, at the end of the day, these three, or literally the economy, works in terms of what the user needs, right? So if the user is requesting to have a specific service that meets something, they will just create it. The same goes for storage and so forth. So once that GCP has also had a lot of adoption nowadays. Before, it was literally all AWS, and Azure was for people running Microsoft for Windows environments. It has evolved, into a way that they both compete. Both AWS and Azure are the main cloud providers, but GCP is now getting a lot of attention as well, just because of the terms of the cost, and also the terms of the big data and how they manage they have access to data services that are top notch in terms of managing data. So then we have jumped to Azure. As you can see, I just tried to put this and this other image on where we have more services, because again, these two main cloud providers have even more services than GCP or some others. There are at least 100 services and more that they both have, and every single one has their own thing. So in here, the same, as you can see, we can have like compute and remote app will be the same as the app engine that we have on GCP. And from that point on, we can have web apps, API apps, and all of these can be categorized as, literally platform as a service. where you can now evolve instead of creating your server in Azure, you can just create your application by submitting your GitHub request, your GitHub URL, and so forth. So you don't need to worry about the actual operating system. And so again, every single thing here in Azure, it also provides like a lot of resilience, and this is one of one of the main concerns when moving to the cloud, right? To have resilience and high availability of your applications. So Microsoft has also enabled some specific services that work with Linux architectures before. Once again, it was full on Windows, but since Linux is one of the also other operating systems that are being used the most, I remember when they launched back like in 2010 or 11, the adoption of how running workloads of Linux in the Azure cloud. And so far they have been doing well. Again, they have a lot of adoption in terms of the enterprise, on where they do a lot of contracts with other companies in order to move their clouds from AWS or GCP into Azure and receive a lot of discounts. So that's literally like a war they have of getting customers in, and developing relationships with customers in order to enable them to use more services, and of course expand more, but at the same time reduce costs, like when optimizing the workloads, right? And lastly, we have AWS. Again, it has been like the main cloud provider since the very beginning, but again has been losing some specific market share with Azure and GCP, but still is one of the main ones, and again has a lot of services. And like for example, in here we can see some specific services for applications and foundational service as well, like for deploying. And the one that it's interesting as well on AWS is how they name their services, right? If you go GCP into Azure and you want a server, perhaps you will try to work to search for compute, right? And you will be able to spin out a server. Whereas on AWS they have specific names, like for example EC2, which is it stands for Elastic Compute version 2, and that's the name of the service on where you will be able to deploy your server, right? So again, there's a lot of things happening on AWS in the terms of also adopting and bringing customers in. Since it was the very beginning, it was the first the major cloud provider. That's why the market share is pretty much was held by them. But nowadays, again, they're perhaps losing a little bit of market share with other cloud providers, but they're still are reliable and one of the strongest AWS services out there, cloud providers out there. I remember back then when I actually started working on where I first heard of AWS, right? I was just learning and working with servers that we depend on, like data centers operators. So we had to reach out to them, hey, we need a new server, and then they would provision the server like in 2 weeks. And as soon as we had the server, we need to deploy and ask for permissions for the applications. And when we first started working at AWS, it was literally a different experience from another planet, right? You could spin out a server by just doing 3 clicks, and then you will have your server up and running, publicly accessible, with you being the full owner, having root access to it. And from that point, we will be able to see a lot of evolution, from the entire adoption and how we deploy our applications into the cloud. So talking about cloud migrations, I believe that was a good introduction into the 3 main cloud providers and how they work and how they correlate, and the market shares as well, and a little bit of history. Talking about cloud migrations, this is an interesting one, and again I mentioned this specific topic because it's one of the main roles and tasks that most of the time we as engineers working with cloud faced. And again, cloud migration, as we have discussed today, we can be talking about moving from AWS into Azure, into GCP into Azure, but we can also talk about moving from on-premise into the cloud. That would be like the main reference that someone says, right? We need to move to the cloud or migrate to the cloud. We will be assuming that they are on-premise and they're trying to move into AWS or Azure. But the reality, as I was just speaking, most of the times we have seen projects on where we need to move from GCP into AWS, or from Azure into AWS, or AWS into GCP, right? So this is now a trend as well. Again, since they are heavily fighting for customers, they perhaps offer a new approach or a new cost to a customer and they then need to switch to this new cloud provider. So this is something, like 5 years ago, it wasn't a thing. Like if you move into the cloud, into AWS, you will be on AWS forever. But now, this is not the case. At the same time, when we're talking about migration, and since we understand now that we have platform as a service and software as a service, we can also be talking about moving for specific services that are running in a specific cloud that is related to a service, right? So again, since we now have platform as a service, companies like MongoDB, Elasticsearch, they have developed their own clouds on where you can now just spin up a specific services like a cloud, a MongoDB cluster in the cloud, and you do not need to worry about, the actual operating system or anything. You just worry about your data. So that's again a managed service that has been evolving, this new trend. So this is also a migration that you need to move perhaps from a MongoDB cluster that is running on Atlas, it's the company, into a Databricks MongoDB cluster, right? That is also running in the cloud. So again, we are now seeing this evolution of migration, not from the cloud providers, but now from the platform providers, right? In this case, as I mentioned, moving clouds, clusters from MongoDB from one provider to another, right? So yeah, it's really interesting to see this topic, and also this is just a theory, but in practice, it's a lot of infrastructure as code that we will see in the next sessions, and that also emphasize the use of these technologies to facilitate the work of moving this specific package, this robot, from one cloud to another one, right? So now finishing off with the Cloud Well Architect framework. Again, this is a framework that was developed by these three cloud providers. Everyone has their own, but they follow the same amount or the same practice. And at the end, they focus on these like three pillars, I would say, of how you can manage and architect your infrastructure, right? Because at the end of the day, when we are working as engineers, as DevOps engineers, cloud engineers, we can also have the title of architect, on where you will be considered like a more senior position, and also you will be able to like deploy and architect the actual solution, right? That we will use these specific services for this component of the application. We will deploy this application or this service in this specific region or in this specific set of servers. So in that case, you start doing diagrams, and at the end of the day, you need to fully focus on these specific pillars, right? Like operational excellence, right? That the procedures and that are following for deploying, managing, and monitoring your application, if they follow specific guidelines. Like for example, having multiple availability zones for your application. So your application needs to be, spawn multiple regions, or in this case, availability zones in the same region. So if a specific availability zone goes down, like a data centers goes down, your application will still be reachable for your end users, right? Then talking about security, right? If we saw, the customer responsibility model, the cloud provider is actually in charge of managing the physical security of the servers, but you, as the end user of these applications or this platform, you are in charge of managing your security in your application, in your servers, right? You will not open, like for example, the ports for your servers to be accessible from anywhere, or like for example, your application will have really TLS enable, you will have certificates, and so those basic concepts, right, in terms of security. But in some cases, we have seen some infrastructures that do not comply to those, so basic compliance. Then reliability as well, protecting and securing the data and assets that are in a cloud-based solution, that your data is reliable and it's not compromised. Again, this follows a lot of set of principles and practices. Like literally, they can be like checklists that you need to apply to your infrastructure and to your services. And the three cloud providers have the same. The performance efficiency as well, that you are able to spin up your servers or your components or your services that you are using, in terms of having them fully efficient to the actual requests that are being made. Cost optimization is one of the most important ones, because again, people is trying to move into the cloud in order to optimize costs, because you only pay what you use, right? You will not be paying like an upfront commitment or an upfront for something that you will not use. There are some specific models of paying upfront that will get you a discount, but it's not the same as paying for something that you will not be using, right? So cost optimization, again, is one of the main components when architecting solutions. And lastly, sustainability. That's a new one on where, AWS has been pushing a lot on, evaluating the design and the workloads to respect for a sustainable future of, CO2 and, leveraging the use of servers and, not trying to just use what you need to use, right? Not over permission and that sort of things, because at the end, it's a thing on the climate change. So this is like the main cloud well-architected framework and the pillars that again should be applied, and we need to know them in order to work with the cloud. So the same goes for, like, for example, in here, you can see the comparison with all three, and they all have like the same approach and the same tools at the same time. These are tools, again, like some checklists. As for the moment, GCP doesn't have one like these specific guidelines, but I believe they are working on it. And yeah, this give you like a big overview that the three cloud providers have the same approach, because again, they are trying to solve the same issue, right? And being able to jump and to attract people to companies into the cloud. And by doing so, it's not about making money and revenue on their side, but also like emphasizing on how to use these tools, how to use the cloud in the best way possible, by applying all this well-architected framework, right? So that was literally it, the reference part. Yeah, I'm not sure if there are any questions out there. Again, this was just a theoretical session. So yeah, if you have any questions, please feel free to ask them now. If not, I really appreciate your time in this workshop. We'll see you on Thursday, and we will start talking about serverless deployment and serverless, and we will be doing a demo of deploying an application multi-region. So that should be interesting. So thanks again for joining, and yeah, have a good day.
See you. Good day.
Thanks.